If you are watching this video, then you should have already completed the activity in class where we graphed absolute value equations. So this is just a follow-up to that lesson. Our parent graph that we used was y equals the absolute value of x. If you substitute the values in, the absolute value of -3 is 3, the absolute value of -2 is 2, absolute value of -1 is 1, and continuing, we get these values. If you plot those points, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. We get a graph that we could describe as V-shaped. So here is our graph for absolute value. And that's actually one of the ways that you can recognize an absolute value graph, is because you will have a graph that's V-shaped. Now this is what we consider the parent graph, so we're going to use this idea, use this graph, when we make changes to the equation. And again, this is the activity that we did in class. So you should know at this point that if it's positive out in front of the absolute, that it's going to open up. If we have a negative in front of the absolute value, it's going to open down. And you also should know that when there's a number in front, that's going to affect the steepness of the V. So here was our parent graph. Let's take a look at some of our graphs if we change this. Remember the slope, if we think of this as a slope, and the parent graph up 1 over 1, and we go both directions. So here are some graphs that we can, some equations we can graph, and we should be able to graph these very easily. Remember, this is the parent graph, and the +1 out here is going to shift it up 1. So my vertex of my V will now be located at the point 0, 1, but it's not stretched and it opens up. So I'm going to go up 1 over 1, both directions. And from that point, I could also continue to go up 1 over 1. And we get a graph that looks like this. Now let's go ahead and list the domain and range. The domain here is all real numbers. The range, notice that the lowest we can go is 1, so we say y is greater than or equal to 1. On the next one, remember what the -1 does. If it's inside the absolute value, it's going to shift it. This is going to go 1 to the right. It always shifts to the opposite direction when you're inside the absolute value. So it's going to shift 1 to the right, and this is going to make it go up 3. So 1 to the right and up 3 is where my vertex will be. There's no stretch in front, there's no number out front, so it's going to go up 1 over 1, just like the parent graph. So we have this graph. My domain is all real numbers. My range, I have y is greater than or equal to 3. 3 is the lowest vertical point I can be at, so y is greater than or equal to 3. On the next equation we have to graph, this +1 is going to make it go to the left 1. The +3 on the outside makes it go up 3. Remember, the negative sign is going to make it open down. And the 2 acts kind of like the slope, so that affects the steepness. So it's going to be a little steeper than my parent graph. So let me start by finding the vertex. I go to the left 1 and up 3. Now I know I'm going to be going down this time, and I know I have a slope, kind of a slope of 2. So I'm going to go down 2 over 1, both directions, to get my V shape. From that point, continue to go down 2 over 1. So my graph looks like this. The domain, still all real numbers. The range, This time it's pointing down. The highest it can be is 3, so y is less than or equal to 3. For the next one, we're going to be going to the right 3 and down 1. So I'm going to move to the right 3 and down 1, and here's my vertex. It's going to be opened, it's going to open up because it's positive, and I have, this is not going to be as steep. It's going to be a little flatter, so I'm going to treat it like having a slope of 1/2. So from my vertex, I'm going to go up 1 and over 2, both directions. I'm going to plot another point, up 1, over 2. So I end up with a wider V. Something like this. Domain, still all real numbers. Range, the lowest I'm at, the y value is -1, so y is greater than or equal to -1. Now this graph is going to be a little different. It's not going to just move 1 to the left. When I need to find the value that it's going to move to as far as horizontally, what I'm going to do is I'm going to set the part that's inside the absolute value. I'm going to set that equal to 0. And I actually could do this on all of them. It's just easier to use the opposite. But if I solve this for x, I'm going to get 2x equals -1 and x equals -1/2. This is still going to do down 3. So my vertex is going to be located at -1/2, -3. So because of this 2, it's also going to shift it. I have to divide by the 2. So I can still do the opposite here and say -1, but then if there's a number up front of the x, a coefficient to the x, you have to divide by that number. So I'm going to plot the point -1/2, -3. Now I have another issue here as well. This still will act on the slope. So because I have the 2 there, I'm still going to treat this like a slope of 2. So from my point, I'm going to go, from my vertex point, I'm going to go up 2 over 1, both directions. And I can do that again, up 2 over 1. And now I can draw my graph. And my domain, all real numbers. And the range, notice my lowest point is at a -3, so y is greater than or equal to -3. Well, we've graphed linear inequalities, and absolute value inequalities are actually quite easy to graph. When we're going to locate the vertex just like we have before. So the vertex is going to be located at -1, -3, because we're going to take the parent graph, go to the left 1, down 3. So my vertex, -1, -3. A slope of 1, so it's going to open up. So up 1 over 1, both directions. The only thing we have to think about, just like we did with lines, is it dashed or solid? So because it's just less than, it will be dashed. So when you draw your V, instead of using a solid line, you'll make a dashed line. The other thing we have to do is we have to shade, and we could test a point. I'm going to test 0, 0. And if I test 0, 0, plug in a 0 for y, plug in a 0 for x, and see if this is true or not. So we get 0 is less than, the absolute value of 1 is 1, -3 is -2, and this is false. So I'm going to shade the side that does not include 0, 0. So I'm shading the outside of the V, or below. Another thing you can do is if you look at the symbol, it's less than, so you want to shade the y values that are less than. Look at the vertex, shade below. On the next one, we're going to start by plotting the vertex, -1, +4. Notice this is going to open down because it's negative. I have a slope of 2, so it's going to be steeper. So down 2 over 1. Continue that pattern, down 2 over 1. Because it includes the equal to part, this is solid. So we're going to draw in this line, or our V shape. So here's my V. And now I need to decide which side to shade. Now I'm going to just use the symbol. It's greater than, so I want to shade the y values that are greater than my vertex. So if you go to the vertex and you want the higher values, which puts me outside or above, but this time it's outside. And that would be the part that I would shade. You could also test a point. If you test 0, 0, you should get a false statement. But that's all you need to do to graph absolute value inequalities.